Any problem in that?
No, ma'am.
Fine. See, I think I actually explained you substance, a singular pure form of matter. I think yes, we did.
Yes, ma'am, we did.
Okay. See, pure substance consists of a single type of particle. In other words, a substance is a pure single form of matter. See, beta here particle can be an atom, which is the case for elements, yes. And particle can
Yes,
also
ma'am.
be a molecule, which is a compound, obviously, in case of compounds. Okay.
Okay, ma'am.
You getting it? In case of
Yes,
atoms, in case of in case of elements, what is the particle which is combining? Same kind of particle, that is atom, right?
yes, ma'am.
You're
Yes,
getting
ma'am.
it? Whereas in case of a compound, which is again a part, again a example of pure matter, there what is the particle which is combining? Same kind of particle is the molecule. Example, beta, example, let's say
Yes, ma'am.
we have H2O. This is one molecule. Okay. Now in water,
Yes,
all the molecules are same. That means this becomes one combining unit, one particle. I hope that is clear,
yes,
right?
yes,
Any
ma'am, it is
problem?
clear. No, ma'am.
So that's all done. Now the next part was the elements and the compounds, and that's we'll start with the mixtures right now. Just a minute. Yes, see. Please go through this theoretical part. Was the first to establish an experimentally useful definition of the element. An element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. You will get it.
Yes, ma'am.
Simpler substances. What does it mean?
Sim it means that into like
See,
O2.
elements which are generally the elements are present around us. Okay, an atom is not existing as an atom. Okay,
Okay, ma'am.
it is existing in the form of an element or in the form of a compound. Do you agree with that?
Yes, ma'am.
And in case of a compound also, there are different elements which are actually combining, right?
Yes, ma'am.
Now do you get this?
Yes, ma'am.
Any problem?
No, ma'am. I got it.
The next is the metals, non-metals. I think we have clearly discussed all the details.
Yes, ma'am,
Then
we
when
did.
yes. So from my side, this part is complete. Obviously, we'll go. Acha, tell me, did you go through these activities, beta?
No, ma'am, I didn't go through the activities. Actually, I just went through the first five few pages only.
Okay, okay,
I
no worries.
didn't
See,
go through the
we'll
full
discuss
book.
it quickly. Actually,
Okay.
what happens when we go through NCRT, beta, since our main focus is NCRT, right? Our syllabus is NCRT. The question paper is actually prepared from the NCRT itself. Okay. Now, what happens in an
Okay.
NCRT, we need to go through each letter, each word, each question mark, each full stop, each activity, so that we are preparing ourselves in a best way, in the best way. Okay. So next
Okay.
time, try to go through the activities also, so that it's easier for us to discuss. No worries, we'll discuss it right now. Okay. See,
Yes, ma'am.
5 grams of iron fillings. Now, iron fillings means what? It's an element of iron, right?
Yes, ma'am.
And 3 grams of sulfur. Again, sulfur is an element which is a non-metal. Okay. So
Yes, ma'am.
both of them are two separate elements. Is it clear? Now,
Yes, ma'am.
individually, both of them are substances. That means both of them are pure matter.
Okay, ma'am.
Now, see what happens to both. Group 1, mix and crush iron filings and sulfur powder. Clearly, we are mixing them. So, obviously, it will not be a very good chemical bonding. Getting it?
Okay, ma'am.
Are you able to
Yes,
recall
ma'am.
that? In case of pure
Yes, ma'am.
matter, the type of bonding that takes place is the chemical bonding, whether in elements or in compounds, right? And hence that is why we are not
Yes.
able to separate them through physical processes of separation, like filtration. Okay. Group 2, what
Yes,
happens?
ma'am.
See, mix and crush iron filings and sulfur powder. Heat this mixture strongly till red hot. Remove from flame and let the mixture cool. See, in this way, what will actually happen? We will see it afterwards. See, check the for magnetism in the material. Often bring a magnet near the middle and check if the material is attracted towards the magnet. Fine. Compare the texture and the color of the carbon disulfide to one part of the material obtained. Stir well and filter. Add dilute sulfuric acid or dilute hydrochloric. See, in the first part, what happens? If only iron fillings and sulfur are there, they are not mixed chemically. Okay. Therefore, it behaves as
Okay,
a
ma'am.
mixture. Therefore, it behaves as a mixture. Now, what happens in a mixture? We'll discuss it right now. In case of a mixture, what happens? The properties of the combining units are there. The overall properties of the
Okay, ma'am.
mixture is the result of the total properties of the combining units. Okay. So if iron is actually,
Yes,
it
ma'am.
is attracted towards a magnet, yes or no? Since
Yes,
it's a
ma'am, it
mixture,
is.
the magnetism will be applied here. Why? Because the properties of iron will be there in the mixture, and hence the mixture will be attracted towards the iron, towards the magnet. Is it clear?
Yes, ma'am, it is
Whereas
clear.
in the second case, beta, whereas in the second case, this will form some kind of a compound, iron sulfide. Why? Because it's heated, and because of that, a chemical bond will form between these two elements. I hope you're getting it. Okay.
Yes, ma'am.
Now, when a compound is formed, the properties of the compounds are completely different from the properties of its combining unit. Yes or no?
Yes, ma'am.
Therefore, magnet will not work on this.
Okay, ma'am.
You getting it, beta?
Yes, ma'am, I got it.
Okay. Now, color and texture, we can obviously know that it's a compound. It will be completely different. It's a mixture. It will be somewhat a mixture of both of them. Yes?
Yes, ma'am.
Fine. Add carbon disulfide to one part of the material obtained, stir well and filter. Add dilute sulfuric acid or dilute hydrochloric acid to other part of the material obtained. See, in this case, it will give you a completely different results. Why? Because it's a compound. Yes. So it will react with these as a compound. Mera, tell me, are you getting it? Are you able
Yes,
to
ma'am.
recall the properties of the compounds that we have discussed?
Yes,
Okay.
ma'am, I can.
And obviously, I discussed it after once we have discussed the mixtures also. But I hope some part of it is clear. Okay.
Yes, ma'am, it is clear.
Fine. See, since in the first part, let me just quickly discuss the mixture part with you. Then I'll discuss that so that you are not confused. Okay. So okay, we are starting with the mixtures. Any problem in the pure matter?
No, ma'am, I got it.
I think we have also discussed the chemical and the physical change. If I'm not wrong,
Yes, ma'am, we did, but we did not discuss that much about it.
we did not. Okay, we'll discuss
No,
it
ma'am.
afterwards. No
We
worries.
just did like an introduction to it.
Okay, we'll discuss it. No worries. See, mixtures. So first, I think we should complete that only because if that, I thought that's completed. See,
No, ma'am, we just discussed the introduction of it. That's all.
okay, no worries. Then though I should not have even started that activity. I thought we have completed this. That's why I started discussing that activity. Sorry for that. See, chemical change and physical change. What happens here? But I hope you know a term which is called as a chemical configuration. Okay. Do you know what do we mean by chemical configuration?
So
Okay.
it
See,
is.
yeah. In this chapter also we discussed that atom is the fundamental unit of matter, right?
Yes, ma'am.
So it is the atom which is actually providing or contributing to the properties of the overall matter.
Yes,
Yes.
ma'am.
So the
Yes, ma'am.
atom also has three subatomic particles. You must be knowing that: electrons, protons, and neutrons.
Yes, ma'am.
How are these three subatomic particles arranged in an atom? Okay, is referred to
Okay.
as the chemical configuration of that atom or element.
Okay, ma'am.
Is it clear?
Yes,
Now,
ma'am. It
if
is.
in a reaction or in a change, let's say there is a change taking place, okay, that change leads to a change in the chemical configuration of the element or the atom. Okay,
Okay, ma'am.
let's say, beta, this is oxygen. Okay, this is oxygen. Okay, and this is wood. Wood means carbon. Okay, wood means carbon. Okay. Now, oxygen
Okay.
has a specific type of electronic configuration. I am denoting it using A. Okay. The carbon also has a specific kind of electronic configuration or chemical configuration, denoting it using B. Okay. Now, what happens when A is actually reacted with B, that is burning of wood? Okay. What happens, beta? Some change in the electronic configuration of A takes place, and also some change in the electronic configuration of B takes place, right? And when the change
Yes,
takes
ma'am.
place, a new substance is formed because of that change. See, it might have lost something, it gained something. Okay. So whatever this has lost is actually gained by B. Just try to imagine it. Okay. I gave you
Yes,
some
ma'am.
amount of money, you accepted that. So your total income increased, mine total income decreased. Yes or no? But some change took place.
Yes, ma'am.
Getting it?
Yes,
So
ma'am.
now this forms a completely different product, that is AB. This has a completely different electronic or the chemical configuration, right?
Yes, ma'am.
Therefore, burning of wood is a chemical change. You getting it?
Yes, ma'am. I got it.
Any problem till here?
No, ma'am, I got it.
Any problem in this? So what happens when there's a change in the initial state and the final state? That clearly means it is a chemical reaction that has taken place. Okay.
Okay,
A
ma'am.
chemical reaction, a chemical change is always represented by a chemical reaction, okay, and a chemical equation. So whenever there's a reaction in an equation, it means it is representing a chemical change that has taken place. In case of a chemical change,
Okay.
a new substance is formed. And why is it formed? I think we have understood it. Why? Because the chemical
Yes.
configuration of the reacting substances changes, which gives rise to an overall new substance.
Okay, ma'am.
Clear? Whereas in case
Yes.
of a physical change, no change in the chemical configuration takes place. Therefore, no new substance is produced. Okay.
Okay, ma'am.
Now let's see. If I say beta, this is if I say beta, this is ice. Okay. Ice is what? Solid water.
Yes, ma'am.
This is H2O. Yes. H2O molecules. Yes or no beta? That's it.
Yes, ma'am.
If I melt it, it will change to liquid water. What will happen? Their arrangement will be somewhat different. They will actually be arranged at some distance. Intermolecular spaces will
Yes,
increase.
ma'am.
I hope you are able to recall it from the first chapter. Yes.
Yes, ma'am, I do.
See, the configuration does not change here. It will be H2O, it will
Okay.
be H2O. Yes or no? If the chemical
Yes, ma'am.
configuration does not change, no new substance is formed. No new substance is formed. That means it is a physical,
Physical change.
physical change. Exactly.
Okay, ma'am.
Any other problem better till here?
No, ma'am, I got it.
Rest, I think we all discussed. Let me just quickly go through the exact to share that. Harshita, what I'll do is that I'll try to arrange one extra class with you every week so that we can go through the questions. Okay.
Okay, ma'am.
I'll try to convey this to the team if that's possible. How many classes do you have
Okay,
per
ma'am.
week overall?
Overall, I have 3 classes.
That's it per week.
Yes,
So we can
actually
arrange.
for physics, I'm taking 3 classes, and for chemistry, only one.
Okay, okay. Math.
No, ma'am, only for physics and chemistry.
Okay, fine. No worries. But please go through this part. The properties that can be observed and specified. Why can be observed? Because obviously chemical configuration is something which is at the chemical level, right? We cannot observe that as such. You get it? So that is a part of the
Yes, ma'am.
chemical change. The properties that can be observed is a physical change. Is are the physical properties. If there is a change in these physical
Okay.
properties, that means it's a physical change. I hope that is clear.
Yes, ma'am.
See what
Yes,
happens.
ma'am.
Ice is a solid state. Okay. Ice, it
Yes,
can be
ma'am.
observed. It's a solid state. Okay. It changes to a liquid state that can be observed. Now clearly it's a physical change, and we
Yes, ma'am.
understood it why it's a physical change. Okay.
Yes, ma'am.
Okay. Please go through it. The properties that can be observed. Having some problem. I don't know what's that problem. Can you see the screen?
Yes, ma'am, I can see the screen.
But there's some problem, right?
No, ma'am, there is nothing. It's clear.
Is it?
Yes, ma'am, it
No,
is
it's
clear.
having some problem, beta. Just a second.
But the thing, it is moving actually.
Yeah, it's not getting stable, right?
Yes, ma'am.
I don't know what's the problem. Let's stop it here. Let's try to start with the mixture, then obviously we'll come back to this. Okay.
Okay, ma'am.
See, mixtures. Finally coming to the mixtures. But you need to, I'm leaving the meeting for a minute. There's some problem.
Okay, ma'am.
I'll join again in a minute.
Sure, ma'am.
Yes, Harshita, is it audible?
Yes, ma'am, you're audible.
Yes. Thank you. Sharing is not turned on. Just give me. Yes, Harshita. Okay.
Okay, ma'am. It's clear.
Thankfully, as of now, yes, but it's having some problem. Okay, fine. So mixtures. Now see. Let's say, beta. Let's try to understand. This is a substance. Okay. This is a substance. That
Okay.
means it's a singular form of pure matter. Yes.
Yes, ma'am.
Again, this is a mixture. Again, this is a substance. Okay. A and B, both of them are substances. Okay. Now
Okay,
what
ma'am.
happens if I mix them? If I mix them, okay. No,
Yes,
but
ma'am.
how is the mixing taking place? They are bonded not chemically but rather
Physically.
physically. Okay.
Okay,
Then
ma'am.
it is referred to as a mixture. Two or
Mixture.
more elements or substances. I'm giving you the definition right now. Don't worry. When two or more substances or elements are bonded, mixed physically, and in a variable composition, and in a variable
Variable.
composition, then it is referred to as a mixture. Okay. See, now what
Okay, ma'am.
happens? Now what happens? In case of a compound, if you remember, there was a very fixed term that was fixed composition by mass. That means always there will be one part of the hydrogen atom and always there will be eight parts of the oxygen atom in a water molecule by mass.
Yes, ma'am.
Do you remember that?
Yes, ma'am.
Or should I tell you that again? You're
Ma'am,
not able to. You're not
can you
able to
tell
recall.
it?
Yes, I can. See, here it is.
Okay,
By
ma'am.
mass, see, H2O has what, two atoms of hydrogen? Yes,
Yes, ma'am.
one oxygen atom, right?
Yes, ma'am.
The mass of one hydrogen atom is 1 unit. We are not concerned with the units here, beta. It's 1 unit.
Okay.
Okay. The mass of one
Yes, ma'am.
oxygen atom is 16 units. Okay.
Okay,
Now,
ma'am.
in case of hydrogen, because there are two, in case of water, because there are two hydrogen atoms, don't you think it will be two mass
Yes, ma'am.
of
It will
hydrogen?
be
Is 216. Why 16? Because there is one oxygen atom which has a mass
one
of 16
oxygen.
units, right? If I calculate the
Yes.
ratio, beta, don't you think it's 1:8?
Yes, ma'am. It
This
is.
was the composition by mass. That means always in a water molecule, in one water molecule, there will be one part of hydrogen atom and eight parts of the oxygen atom in the mass of the water molecule. I hope that is clear.
Yes, ma'am. It is
Are you
clear.
able to recall that?
Yes, ma'am. I'm able to recall now.
Yeah. So the point is that in case of a substance and specifically in case of a compound, what is the point? The point is that there's a fixed composition by mass. There is no
Okay.
variable composition. Whereas in a mixture, beta, what is happening? Harshita? In case of a
Yes,
mixture,
ma'am.
what is happening? There is variable composition with a yes or no?
Yes, ma'am.
Okay. See what happens. I'm telling you one thing. Element is clear cut a case of pure substance. Yes, clear cut. Same kind of items, pure substance, right? Now the point is,
Yes.
at times people get confused that whether compound is a pure substance or not. Why? Because see, in case of compound also A and B are combining together. Yes.
Yes, ma'am.
In case of mixture also A and B are combining together. Yes. But the way they are
Yes.
combining is different. In case of a compound, it's a chemical bonding. In case of a compound, it's a fixed composition. Yes. Whereas in case of a
Yes, ma'am.
mixture, it's not a chemical bonding, rather it's a physical bonding. Okay. It's a variable
Oh,
composition. Are you getting? So that is why I'm saying
yes.
these are the major differences between a compound and a mixture that makes compound an example of pure substance, whereas mixture is an impure substance, impure matter.
Okay, ma'am.
Any confusion in this?
No, ma'am. I got it.
Any confusion? All clear?
Yes,
See,
ma'am. All clear.
look here. Matter was there? Yes. It was pure and impure. Yes. Pure was
Yes.
elements and compounds. We completed this. We are coming to
Yes.
impure matter. Yes. Impure matter is referred to as a mixture. Okay.
Mixture.
Whereas pure matter was referred to as a
Substance.
substance. Is it clear, beta?
Yes, ma'am.
So now we are studying about the mixtures. Okay. And what is a mixture,
Yes, ma'am.
beta? What is a mixture? Please write it down.
When we combine
Yeah, write it
different.
down. Have you
Yes,
written
ma'am.
it down? Have you written it down, beta?
Ma'am, the definition I didn't write it, ma'am.
Yeah, write it, write it. If you
Okay,
want to
ma'am.
write it, write it. Should I dictate it or you don't want to write it?
Ma'am, you can dictate it.
Okay, write it. When two or more elements or substances, when two or more elements or substances
Yes, ma'am.
combine together,
Yes, ma'am.
bonded physically, bonded physically, okay,
Yes, ma'am.
in a variable composition, in a variable composition,
Yes, ma'am.
then it is referred to as a mixture.
Yes, ma'am. I
Okay,
completed.
done.
Yes, ma'am.
See, now you have understood those two very important properties. A, that there is no fixed composition, and B, they are not bonded chemically. Okay.
Yes, ma'am.
These two changes actually have completely different changes in mixtures, whereas in compounds they have completely different properties. So much so that the compounds are an example of pure matter, whereas mixture is an example
Impure matter.
of pure matter. Is it clear, beta? Can I move ahead?
Yes, ma'am. Yes, ma'am.
See, the mixture is also of two types, beta, homogeneous
Homogeneous.
and
Mm,
heterogeneous. Okay. See, hetero means different. Hetero means
different.
different. Homo means same. Homo means
Sa-
same.
Same.
What happens, beta? Both of them are mixtures, but in case of a homogeneous mixture, let's say let's say we have two substances, beta, A and B. Yes, these are combining to
Yes.
form a mixture. If it is a homogeneous mixture, what will happen is that the mixing will be evenly distributed. The mixing will be even throughout the mixture. Okay, there will be
Yes.
uniform distribution. There will be uniform mixing. You get this? It will
Yes,
not
ma'am.
happen that, let's say, beta, we have a mixture like this. Okay, it will not be like this. At this point we have B, 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 and just one A, and at this point we have A, and just one B. Okay, homogeneous mixture will mean that at all points it is A, B, A, B, A, B, A, B, A, B. Getting it, beta?
Yes, ma'am. I got
That
it.
is an example of homogeneous mixture. That is, there is homogeneity all throughout the mixture. There is uniformity all throughout the mixture. There is even distribution all throughout the mixture. Is it clear?
Okay, ma'am.
Clear?
Yes, ma'am. It is clear.
Now see what happens. In case of a, see, obviously in case of a homogeneous mixture, what happens is that there is no clear distinction between the boundaries of the combining units. Okay, combining unit.
Okay, ma'am.
Let's say, beta, what happens? Let's say we have A and B. Okay, they are in a mixture. They are a mixture. Okay, but we'll not be able to tell which one is A and which one is B. Okay,
Yes, ma'am.
Is it clear?
Yes, ma'am.
The examples are beta lemonade. You know a lemonade?
Yes, ma'am, I do.
Lemonade is what? We mix sugar, we mix water, we mix salt. Yes,
So, yes,
we
ma'am.
mix lemon juice. Okay. Now all these three are substances on their own. This is water. This is a compound. This is a substance. Yes. This is sugar, beta.
Yes,
This
ma'am.
is a compound. This is a substance. Yes. Beta,
Yes,
this is a salt. This is a compound. This is a substance. Yes. This is lemon
yes,
juice. Okay, this is a substance again, a compound. Okay. What
yes,
happens?
ma'am.
We mix them. We mix them. And clearly, no chemical bonding takes place. Okay. You might add more sugar. I might add less sugar. You might add more lemon. I might add less lemon. Yes. Clearly, there
Yes,
is
ma'am.
no fixed composition. Therefore, there is variable composition. Yes or no?
Yes, ma'am, there is.
Therefore, it is a mixture. Therefore, it is a
Mixture.
mixture. Now, what kind of mixture? In case of lemonade, you cannot differentiate which one is a lemon particle, which one is a sugar particle, which one is a water particle, which one is a salt particle. Okay. Or it will also not happen if it is mixed properly, obviously, that at times you will sip it and you will feel very tasty. At times you will sip it, you will feel very salty. No. Generally, if it has been mixed properly, the taste will be uniform throughout. Yes or no?
Yes, ma'am.
So that is why it is an example of a homogeneous
Mixture.
mixture. I hope that is clearly understood.
Yes, ma'am,
Any
it is
problem
clear.
till here?
No, ma'am, I understood it.
And one more property of a mixture is that, see, we studied two properties. A, no physical, no chemical bonding, only physical bonding.
Yes, ma'am.
Yes. And second is that variable composition. Yes.
Yes, ma'am.
Third is that, the properties of a mixture, the properties of a mixture are a result of the combining units of the mixture. They are not different. They are a result of the combining units of the mixture. See, in case of
Yes,
lemonade, it is also a bit sweet because of the sugar. It's also a bit salty because of the salt, right? It's in the liquid state because of the water. It has some sour taste because of what?
yes,
The
ma'am.
acid. Okay, you getting it better?
Yes, ma'am, I got it.
So if you want to note it down, please note it down. The one property of the mixture is also that the properties of a mixture are a result of the combining units of the mixture.
Okay, ma'am.
Done? Can I move ahead?
Yes, ma'am.
And one more property, you can actually use it to differentiate compounds and mixtures, is that elements, compounds, or pure substances, they were actually not separated using a physical method of separation,
Okay, ma'am.
right? In case of a mixture, we can separate most of the mixtures, the combining units of the mixtures, using a physical process of separation.
Physical process.
I hope
Okay,
beta
ma'am.
that is clear. Any problem?
Yes, ma'am. It is clear.
Any problem, beta, you can please ask without any hesitation.
No, ma'am, I got it.
Wonderful.
I
Okay.
understand.
So lemonade is one example of a what? A mixture. Which kind of mixture? Homogeneous
Homogeneous
mixture.
mix.
Okay. Now we want to discuss the homogeneous mixture in detail. Okay.
Okay, ma'am.
Beta, a homogeneous mixture is referred to as a what is it referred to as?
Solution.
A solution. Okay. What is it referred to as? A solution. Okay. Now see what happens. In case of a solution, beta, there are two components. Generally, there are two components. Okay. One is taken as the solute beta. The other is taken
Yes,
as the
solvent.
solvent. Solute generally is the one which is in less quantity. Yes.
Yes, ma'am.
And solvent is the one which is in greater quantity. Okay. Is it clear?
Yes, ma'am.
Now I want to hold on this and I want to discuss another topic which is alloys. See, now when I say matter can be of two types, pure or impure, right? Now there were three states of matter if you're able to recall: solid, liquid, and gaseous. Okay. Whether the matter
Yes,
is pure or impure, we saw it in case of metals, elements, and elements that they can be in all three forms: gaseous, liquid, and solid. Yes, even if they're pure
yes,
matter. In the same manner, the impure matter, which is a mixture and a homogeneous kind of mixture, it can also exist in all three states of matter. Is it clear? Is
yes,
it
ma'am.
clear? Lemonade is one example in the liquid state. Yes or no? Right?
Yes, ma'am.
Beta C. There's another example that I'm giving you, that is air. Air is a homogeneous mixture. It's a mixture. And what kind of a mixture?
Homogeneous mixture.
And what state is it in?
It's in gaseous state
Exactly, it's in the gaseous state. Why is air a mixture?
because there are different types of gases mixed
Mm-hmm.
with each other.
Okay,
Like in the air, there might be oxygen, carbon dioxide, nitrogen, and all.
wonderful. So it's a mixture. Are they bonded chemically or physically?
They're bonded physically.
Physically.
No,
And
I can.
secondly, sorry.
No, man.
And secondly,
What were
tell
you
me,
saying?
is the you saying something?
No, you were telling something. So
Yes, I'm saying something. I'm saying
okay.
my question is the composition of air variable or is it fixed?
Um, so-
See, see beta. We at times say nitrogen is fixed, it's 78%. Yes,
yes, ma'am.
oxygen is also fixed, 21%. Then why is the
Yes,
air mixture?
it's,
Mm-hmm. See, beta,
it's
at times, yes, you have some answer, please share that.
it's due to because there are other particles of gases mixed together right now, so that's why it's a mixture.
See, wonderful. See, generally it's a mixture because of all the major properties which are inclining towards a mixture. Okay. See, first of
Okay,
all,
ma'am.
different elements and substances they are mixed together, not chemically but physically. Okay. That's the major
Yes,
point.
ma'am.
Okay. Secondly, beta, all the major gases that do not change in the composition, they are fixed. That is oxygen and nitrogen. But at times you must have seen H2O, which is also a major part of the atmosphere or the air. It changes. At times the humidity is higher and at times humidity is very low. Yes or no? At times, CO2
Yes,
levels
ma'am.
also may increase or decrease depending on the pollution level, right or wrong.
Yes, ma'am.
So you're getting it? Getting it?
Yes, ma'am. I got it.
Also, yes, also we don't need any form of chemical separation methods to separate these mixtures. Fractional distillation is okay to separate them, right?
Yes, ma'am.
All these properties the are actually the towards the properties of the mixture rather than towards the properties of pure substances. I hope that's clear.
Yes, ma'am. It is
Any
clear.
problem in this point?
No, ma'am. I got it.
So liquid we have understood, gaseous we have understood, right? A very
Yes, ma'am.
important point, beta, that I need to discuss is alloys. What are alloys?
Alloys.
Do you have any idea regarding these alloys, this term alloy?
And they are
You can
made up
say
of
it
like
without any
different metals, right?
different.
Different types of metals.
Uh-huh. Okay. Okay. What else?
And
Yes. See, let us see. Alloys means a mixture of two or more metals. Okay. A
okay, ma'am.
mixture. Actually, tell me one thing I actually forgot to ask you this. In case of air, which is a homogeneous mixture, right?
Yes, ma'am.
Why is it a homogeneous mixture and why not a heterogeneous mixture?
Um,
Hmm. At your place, is the concentration of air same throughout or is it different? At your place, there is more oxygen. At my place, there is more nitrogen. Is it something like that?
no, ma'am.
Is it uniform throughout?
Yes, ma'am. It is uniform throughout.
Hmm. So can it be referred to as a homogeneous mixture?
Yes, ma'am. It can be a homogeneous mixture.
Harshita, you sound a bit confused, not very satisfied. Any questions?
No, ma'am. But I think like the air cannot be different in every place right now. It will be the
Yeah,
same.
that is why it is a homogeneous mixture. Okay. I just wanted to say that. We
Okay,
have
ma'am.
seen that homogeneous mixture has uniformity all throughout. Yes, we discussed it. Yes, beta.
Yes, ma'am.
I just wanted to explain that. Fine, wonderful. Okay. Alloys coming back to alloys, a mixture of two or more metals. Okay, is it clear? See,
Okay,
beta.
ma'am.
I would want to explain you one thing here. Please pay attention. I would first give
Yes.
you one example, that is brass. Okay, brass is an alloy that is a mixture of zinc, which is 30% in this, and copper, which is 70%. Okay.
Okay, ma'am.
Now, what happens, beta? In case of a alloy, because it's a mixture, clearly there should be no chemical bonding. Yes,
Yes, ma'am.
but actually, what happens? There is a chemical bonding between the metals that take place. But it is not referred to as a pure substance or not referred to as a compound because all of the properties of alloys are actually towards the properties of mixtures rather than that of pure substance. Okay, see what happens.
Okay.
Alloys, they have a chemical bonding, that is true. Okay, but they do have a variable
Yes.
composition. At times you will find that there is 35% of zinc and there's just 65% of copper. There is no hard and fast rule that it has to be 30 and 70%. Okay, this is just the average values. Okay.
Yes, ma'am.
Secondly, it's a homogeneous mixture. Why is it a homogeneous mixture? Because it is uniform all throughout. Okay. Example, beta.
Okay.
Example, if I say this is a brass square, okay, a piece of brass, okay,
Yes, ma'am.
it will not be like at here there's copper, 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 and zinc, and here there is zinc only. Okay, no. At every place there is 30% of zinc and there is 70% of copper. Get it? There is uniformity all throughout. I hope this point is absolutely clear. And thirdly,
Yes, ma'am.
one more most important point is that alloys actually are a mixture of two or more metals, yes. And the properties
Yes.
of alloys are actually a result of the properties of the combining units of the alloy. Example, the brass has properties which are a result of the properties of zinc and copper combined together, which clearly is an indication of it being a mixture. Is it clear?
Okay, ma'am.
Any problem
Yes,
till
ma'am.
here?
No, ma'am, I got it.
I think I'm
It's
going
clear.
very fast. Is it okay?
No, ma'am. It's easy.
Right?
I can understand it.
Oh, wonderful. Okay. So alloys, they have one exceptional point from which is different from the mixture. That is, they are bonded chemically. Okay. Otherwise, all properties of alloys are actually towards the properties of mixtures, and hence alloys are a mixture. That means impure matter. And what is state of matter? Solid.
Solid.
I hope the point is absolutely clear.
Yes, ma'am, it is clear.
Okay. If there is copper and tin, it becomes what? What does it become? It becomes bronze. Okay.
Bronze.
So
Okay,
I
ma'am.
will give you a list of all the different alloys. Don't worry. Okay.
Yes.
Iron and carbon together gives you steel. Okay. So we have different
Okay.
list of alnico gives you aluminum. I mean, alnico is an alloy of aluminum, nickel, and cobalt. All of these are different alloys. We will give you a list. Okay.
Okay, ma'am.
Tell me any problem till here.
No, ma'am, I got it.
Wonderful. Now coming to our next point. See, I told you this is a solution. Yes, I told you this
Yes,
is a
ma'am.
solution. Homogeneous mixture. What happens, beta? In case of a homogeneous mixture, let's say, beta, these are the particles of A. Okay,
Yes,
and
ma'am.
these are the particles of B. Okay, what happens here?
Yes, ma'am.
The particles of one element of a substance are actually dissolved in the particles of another substance or a this compound. Okay, they're actually
Yes,
dissolved.
ma'am.
Please mark this word dissolved because in other types of mixtures that we will study, they are not dissolved. Okay, so here what
Okay.
happens, beta? What takes place? Dissolving of the
Yes, ma'am.
particles take place. Okay, it takes place. Is it clear?
Yes, ma'am.
Now the properties of the solution are due to this. Clearly, there is no distinction in the boundaries. Why? Because dissolving has taken place. Okay. If I say, beta, this
Yes.
is water molecules, and these are sugar molecules which have actually dissolved in the water molecules. You understand this, beta?
Yes, ma'am.
So will you be able to differentiate the water molecules and the sugar molecules? Obviously, if it has been mixed properly.
What, ma'am? I couldn't hear you.
I'm saying if water molecules and sugar molecules have been dissolved properly, will you
Yes,
be
ma'am.
able to differentiate between the particles of water and particles of sugar?
No, ma'am, I
Right?
cannot.
It is because actually there is no distinction between the boundaries of different particles in case of a homogeneous mixture, which is also called
Yes.
as a solution, because in case of a solution, dissolving of the particles takes place. I repeat,
Okay.
I repeat?
Yes, ma'am.
Okay. I'm saying in case of a homogeneous mixture, there is no clear distinction between the boundaries of different particles because, and this is a solution, homogeneous mixture is a solution, okay? Because in
Yes,
case of
ma'am.
a solution, dissolving of particles takes place properly.
Okay, ma'am.
Is it clear?
Got it.
So in solutions, the properties of the solution are because the dissolving has taken place. Is it clear, Bache?
Yes, ma'am.
Okay. Now coming to the properties of the solution, beta. Can you tell me quickly the properties of solution? See, beta, first point, please understand this very nicely. First of all, it's a homogeneous mixture. Yes,
Yes, ma'am.
it's a homogeneous mixture. Yes.
Yes, ma'am.
Secondly, what is it? Does dissolving takes place here?
Yes, ma'am.
Acha,
Dissolving
tell me,
takes.
if these sugar particles had been very big, will dissolving take place or no?
Uh, yes, ma'am. Dissolving will take place.
It will not take place. See, the particles have to be almost of a very small size, of a similar size, right?
Yes, ma'am.
Then only the dissolving can take place. Okay, beta. So
But
dissolving takes place because
but
the
ma'am,
size of the
on heating it, it would dissolve, right, ma'am?
on heating it will dissolve. Then it can also change into a chemical substance, which is not the case here.
Okay, ma'am.
You getting the difference?
Yes, ma'am. I got it.
I will discuss this point, the size issue, but as of now, the property beta, the second property is that in case of a solution, the particle size is very small, which is less than 1 nanometer. Therefore, it is able to dissolve. Okay.
Okay, ma'am.
I hope this point is clear, beta.
Yes, ma'am. I
Okay.
got it.
The next point, very important. Beta, these are the properties of a solution. Okay.
Yes, ma'am.
The next point is that if the solution is left undisturbed, okay, if the solution is left undisturbed for a long time, it is not that some particles will settle down at the bottom of the container. No, it will be the same as it is. Will laminate settle down at
Okay.
the bottom of the container?
No, ma'am. It won't.
Right? Why will it not? Because it has been dissolved properly. Yes. So the particles
Yes,
of the
ma'am.
sugar will be in between the particles of the water. Try to imagine it.
Yes.
You're getting it?
Yes, ma'am.
So
I
what
got it.
happens? It is a stable mixture. Stable mixture means what? That it is stable all throughout, and if it is stable, no particles will settle at the bottom. Getting it?
Okay, ma'am.
Therefore, it's a stable mixture. If it is left undisturbed for some time, no deposition will take place at the bottom of the container.
Okay, ma'am.
Is it clear, beta?
Yes, ma'am. It is clear.
Very important point next, no Tyndall effect. What is Tyndall effect? Any idea?
No, ma'am. I don't know what that means.
What happens? These are the particles, okay? These are the particles. These are the
Okay,
rays
ma'am.
of light. What happens if the rays of light are able to pass through the particles and then scatter the light? The light is scattered. That process is called as Tyndall effect. Okay, that
Okay,
process
ma'am.
is called as Tyndall effect. But in this case, no scattering of light takes place. That means no Tyndall effect takes place. Why does it not take place? Because the particles are very small, right? What happens?
Yes, ma'am.
Just try to imagine it. Better. Let's just try to imagine one thing. If I actually put large footballs or basketballs in your way, okay, very
Yes,
large,
ma'am.
obviously you will get obstructed by them. You will come in contact with them, and due to that, you might change your route. Yes or no?
Yes, ma'am.
Right? So then the rays is actually getting scattered by the. You are getting scattered by the footballs, right? You're getting it.
Yes, ma'am.
Now what
Yes,
happens if I say the particles are very small? Will you get obstructed by them?
no, ma'am.
Will you change your way because of them?
No, ma'am. I won't.
You're getting it. So because in case of
Yes.
a solution, the particle size is almost is very, very, very small, less than 1 nanometer. Okay. Less than one
Okay.
nanometer. What happens? There is no Tyndall effect. What is Tyndall effect? There is no scattering of light. And if there is no scattering of light, you cannot see the path of the light. Getting it better?
Okay.
No Tyndall effect. There is cannot see the path of the light. I hope you are getting it better.
Yes, ma'am.
Any problem, I will repeat it again, no issues.
Ma'am, I got it.
See what happens, you must have seen this at times when in a very dark room and there is a small ray of light coming, you can see the particles, right? And also you can
Yes,
see the
ma'am.
path of the light in which it's coming. That is because those particles are there, are big enough to obstruct the light, okay, to scatter the
Yes,
light,
ma'am.
and then because of that scattering of light, we are able to see the path of the light. Getting me?
Yes, ma'am. I got it.
You do one thing, you try this thing. Whenever it's possible, you make a lemonade or you dissolve sugar or salt very properly in water. Okay, there should be no
Yes,
saturation. Then, if you pass light through it, you will not be able to see light.
yes,
Yes, Harshita, audible? Yes,
yes,
I
ma'am.
think.
You're audible.
I'm sorry for this much of disturbance today, beta.
It's okay,
There's some
ma'am.
problem. Sorry for that.
No problem.
Thank you. Okay. So, in case of solution, the particles of the solution are so small that they are not able to scatter the light. That means there is no, but this is scattering of light, okay, this phenomenon of scattering of light is called as Tyndall effect. That's it. Okay. And if
Okay,
there is
ma'am.
no Tyndall effect, obviously there's no path of the light which is visible. Okay. The path of the light is not visible. We are not able to see the
Yes,
path of the light. Is it clear? So these
yes,
are the
ma'am. It is.
four very important properties of the solution. It's a homogeneous mixture. Okay. The particle
Okay,
size
ma'am.
less than 1 nanometer. What is one
Yes,
nanometer, beta? So 1 nanometer means 10 raised to the minus 9 meter. Okay. You're getting it? It's very small.
okay, ma'am.
It's stable. Why stable? Because if it's left undisturbed, there is no settling down at the bottom of the container. Okay. Why does that
Yes,
happen? You can imagine that because the particles are so small that dissolving has actually taken place. Okay.
yes,
And
ma'am.
therefore, there is no clear, therefore, there is no clear distinction between the boundaries of different particles. Okay. And fourthly,
Okay.
very important, Tyndall effect, no path of light visible. Any other
Yes, ma'am.
problem here?
No, ma'am. I got it.
Wonderful. Now, coming to the next part. Okay. See, a solution, as I told you, a solution has two parts, beta. A solute and a
And the solvent.
solvent. Okay. Generally, part of the solution that is less is referred to as a solute, and which is larger in quantity is referred to as a solvent.
Solvent.
Okay. Now, see, there are different ways to measure this. There are different ways to measure this. And what are those ways? See, first of all, beta, first of all, there's saturated solution, okay, and unsaturated solution. Okay, please try to understand this. Okay. See what
Yes,
happens.
ma'am.
If I say, uh, there is a bag, okay, there's a bag which can have at maximum 10 clothes, okay, which can have at maximum 10 clothes. If the 10 clothes are there, don't you think there's no other cloth that it can fit, right?
No, ma'am.
Right? So it is fully filled. Yes, it is fully filled.
Yes.
That means it is saturated. It cannot have any other cloth because it's filled till its maximum capacity. You're getting it?
Okay, ma'am.
Saturated
Yes, ma'am.
means completion. Completion. It cannot have
Okay.
beyond that. Okay. Whereas if I say a bag that can have 10 clothes, 10 clothes has 8 clothes in it. Okay. Obviously, it
Yes,
can
ma'am.
have two more clothes. It's not fully
Yes,
filled.
ma'am.
It's not saturated, that means it's unsaturated. I hope you're getting the difference. Okay.
Yes, ma'am.
What happens, beta? What happens? Let's say, beta, there is 100 ml of water. Please try to understand this. There is 100 ml of water. Okay. It
Yes,
can
ma'am.
have a maximum of, let's say, 20 grams of salt. Let's assume, okay, just maximum of 20 grams of salt.
Yes,
If this much amount of salt is present in this much amount of water, that means it is saturated. You getting it? No.
yes, ma'am.
Understanding?
I got it.
Whereas
Yes,
if I
ma'am.
say
I got it.
in 100 ml of water, there's just 15 grams of salt. That means it can have some more salt which will get dissolved in it.
Yes,
Then
ma'am.
that type of solution is called as.
Unsaturated.
Now see what happens. If I say, beta, if I say even if I add 5 grams extra salt here, will that salt be dissolved in water? No. That can be
No,
added,
ma'am.
but it will not get dissolved in water. At times, you must have seen we keep
Yes,
on mixing the salt or the sugar in water, but it does not get dissolved. Why? Because there is saturation of that much amount of water. If you add more water,
yes,
it will get dissolved. You getting it?
yes, ma'am.
Any problem here?
No,
Okay.
ma'am. I got it.
Beta, please try to understand this. If I say, beta, there is temperature that is 13 degrees Celsius. Okay. There's a specific temperature. Let's say that is 30 degrees. Okay? At this temperature,
Yes,
let's say water molecules are at this much of distance. Please try to understand this. Okay. This much of distance.
yes,
Now what happens, beta, if I increase the temperature to, let's say, 50 degrees Celsius. Okay. Please recall it from the first chapter. Clearly, the kinetic energy will increase. The movement of the particles will
yes,
increase. Yes or no? So don't you think they will
yes,
become at a distance like this? Assume it, right?
yes,
Now, clearly, if they were able to, earlier they were able to have three molecules within them. Yes. Okay.
okay, ma'am.
Now they're able to have six molecules. Yes or no?
Yes, ma'am.
So clearly, the saturation will the amount that can be there in a given amount of water or solvent will increase. Yes or no?
Yes, ma'am.
Let's say even now there are 30 grams of salt, yet it's not saturated. Why? Because it's at a different temperature. So saturation of a liquid or of a solution is always measured at a particular temperature. Why? Because if the temperature changes, if the temperature increases, the saturation point can increase. If the temperature decreases, the saturation point can also decrease. I hope you are getting that.
Yes, ma'am.
You getting that, beta?
Yes, ma'am. I got
Any
it.
problem in this? Next
No, ma'am.
point here, which is very important, is solubility. See, the amount the amount of solute that can make a solution saturated, the amount of solute that can make a solution saturated at a given temperature, at that temperature, is called as the solubility at that temperature. Okay. You
Okay,
getting it?
ma'am.
As in case, let's
Yes,
say 20 grams of salt is enough to make 100 ml of water saturated at, let's say, 30 degrees Celsius. Okay. So this is the solubility of water at this temperature. But if I change the temperature, the solubility will also change. I hope you're getting it.
yes, ma'am.
Any problem, Harshita?
No, ma'am. I got it.
I'm stopping it here. Okay.
Okay, ma'am.
In the next class, we'll continue from this, but please go through the NCRT, this part of the NCRT. Okay.
Sure.
And go through